Hello students, welcome to Vyas Edification Kota. In this series of NCERT EDIFICATION, we'll continue further with Mathematics Class 11, the chapter of Conic sections. And today is the turn of exercise number 11.3 that we'll be dealing over here. This particular exercise, as we said in the previous session also, this is based on the topic ellipse, right? And the standard forms of ellipse, various standard forms of ellipse. There are two standard forms, and the exercise is based on finding the various things related to the ellipse standard form, that is foci, major axis, minor axis, vertices, lattice rectum, eccentricity, and all of those things, right? So along with the questions, we'll be seeing the concepts related to those questions as well, right? Let's begin with the first question here. The question says, in each of the exercises 1 to 9, find the coordinates of the foci. Okay, foci are important, vertices are important, A. The length of major axis, minor axis, okay, major and minor axis are important, 2A, 2B, length of major axis, minor axis, eccentricity and the length of lattice rectum. Eccentricity is also important, length of lattice rectum. All of these things are required, right? Now, we have two standard forms of the ellipse. Let me deal with both of those forms, both the forms over here, right? If the major axis lies along the x-axis, this is x-axis, this is y-axis, this is the center, which is the origin as well, right? So if we have x square upon a square plus y square upon b square equals 1, this is the equation of ellipse where a is greater than b, then the x-axis will be the major axis and these points will be the vertices of this ellipse, right? Okay. The other form is this. Here, equation will look similar. Equation will be x square by b square plus y square by a square equals 1. And once you observe this, here once again, the denominator of y square is bigger as compared to denominator of x square. So we'll get this kind of ellipse. This is vertical ellipse and this is a horizontal ellipse. Okay. Here also I have written under y square, I have written a, and if you observe, this a is greater than b for this one, right? So what are the properties of these, right? The foci will lie on this major axis over here. Okay, the vertices are these. Major axis will be this length 2a, minor axis will be this length 2b over here. Okay, what else? Lattice rectum will be 2b square upon a, right? So let me write those things. Lattice rectum will be 2b square upon a over here. This is important, right? Okay, and what else? Foci. Foci will be plus minus c comma 0. And what about the value of c? C is equal to c square will be equal to a square minus b square for this case, right? This is what we have. Okay, and in this particular question, you can observe that a is greater than b. Lattice rectum will be equal to what? First of all, let's analyze. This will be the minor axis, this will be the major axis, and the foci will be here on this major axis, right? These will be the vertices. These will be the vertices, the coordinates of the vertices. Denominator of y will decide that 0 comma a, 0 comma minus a. Okay, this is 0 comma c, 0 comma minus, 0 comma plus c, and 0 comma minus c. These will be the foci. The ends of minor axis will be b comma 0, 0 comma, minus b comma 0. This is what you have. Major axis will be this 2a, minor axis will be 2b. If you observe here also, this will be a comma 0, this is minus a comma 0, and major axis will be 2a, minor axis will be 2b, right? Foci will be 0 comma plus minus c. Lattice rectum here as well, the lattice rectum will be 2b square upon a. Don't make a mistake over here. Lattice rectum will be 2b square upon a. Foci will be on the y-axis, 0 comma plus minus c, right? And here c square is again equal to a square minus b square, right? This is what we have. Anything else? Vertices, you can identify the vertices in each of these. This is a comma 0, and here the vertices 0 comma a, 0 comma minus a. Those are the few things that we have with regards to the ellipse in standard form, right? Those are some concepts which are useful, right? Which are useful and which will be used to solve such a question. So for this one, x square upon 36 plus y square over 16 equals 1. Do you observe that the denominator of x square is greater than the denominator of y square? Yes. So yes, this will be a horizontal ellipse. Okay, if this is a horizontal ellipse, can we identify the other few things? Yes, let's identify the values of a square is 36, a will be equal to 6. B square is equal to 16, which implies that b will be equal to 4. Those are two important things. On the basis of this, c square, which is equal to a square minus b square, can be identified. What is that? A square minus b square, which will be 36 minus 16, this will be 20. This will give me c square is equal to 20, or c, simply the magnitude of c. If you want to find the magnitude of c, this will be equal to 2 square root of 5. This is c for us, right? One more thing which is required is eccentricity. Eccentricity is equal to c by a. Eccentricity is simply c by a, which tells me that eccentricity will be equal to 2 root 5 upon 6. This is the eccentricity for horizontal ellipse. What about in case of vertical ellipse? Once again, you can have c by a over here as well, right? The lengths c and a will be important for finding the eccentricity, right? What else? So once we have identified a, b and c, we can easily say focus, axis, vertices, coordinates of the foci, the vertices. These are the vertices, right? The major axis, the minor axis, we can easily identify those things. We have found the eccentricity. One more thing remains, lattice rectum. With the help of b and a, we can find the lattice rectum as well. Yes, those are some things which are easily found after having this much information in mind. So let me write the answer after this. The final answer that can be written over here will be foci. Foci will be plus minus c comma 0. So plus minus 2 root 5 comma 0. These will be the foci for this horizontal ellipse, right? Next, vertices, the vertices. So vertices will be plus minus a comma 0, that is plus minus 6 comma 0. One of them is plus 6 0, plus 6 comma 0, the other is minus 6 comma 0. Next, major axis. The major axis can be written over here. Major axis, which is 2a will be equal to 12. Okay, what about the minor axis? Minor axis, which will be 2b. Minor axis will be 2b. This length over here, this is 2b, and that will be equal to 8. Okay, eccentricity, we have already found the eccentricity. This is the eccentricity, and one last thing remains, and that is the lattice rectum, which will be 2b square upon a. Okay, I'm writing this, and the lattice rectum, which will be 2b square. 2 times b square upon a, 2 times 16, that is 32 upon 6, which is 16 by 3. In this question, this is the lattice rectum, and yes, that's the answer for this question, right? This, and this. Right, that's the final solution for this complete question based on the two standard forms of ellipse. Here we required the horizontal ellipse. And maybe in the next few questions, we'll see this vertical ellipse as well, and then I'll directly draw this diagram or this diagram, right? So that's the complete solution for this first question. I'll get aside for a bit so that you can take a look at this complete solution. And now we'll be taking a look at the next question. The second question, as you can see, x square upon 4 plus y square upon 25. Okay, the denominator of y square is bigger. So this will be a vertical ellipse now, right? Here we'll have a vertical ellipse. Okay. This is 0 comma c, this is 0 comma a. Okay, similarly you have 0 comma minus c, 0 comma minus a, this will be b comma 0, and this will be minus b comma 0. So let's identify the values of a, b and c first of all. X square upon 4 plus y square upon 25 is equal to 1. For this, the first thing, a is greater than b, so a square is 25, a will be equal to 5. B square is equal to 4, b will be equal to 2. C square is a square minus b square, which tells me c is equal to under root of a square minus b square, considering only the positive value, right? Plus minus c can be taken care of later. So C will be this, which is 5 square 25 minus this, which is 21. C is equal to square root of 21 is what I observe over here, right? A, B and C have been identified. Okay, so we can easily write coordinates of foci. First of all, foci, the coordinates will be 0 comma plus minus C, 0 comma plus minus square root of 21. That's something which I can write. That's one thing. The vertices next. Vertices, as you can observe, will be 0 comma A, 0 comma minus A, which will be 0 comma plus or minus A, which is 5. What next? The length of major axis. Major axis length will be 2A, which is equal to what? Major axis will be this 2A, which is equal to 10. Minor axis, the length will be equal to what? This is 2B and it will further be equal to 4. We have found 4 things, but 2 more things remain: eccentricity and the length of lattice rectum. So for eccentricity, we have eccentricity is equal to C upon A. That tells me that E will be equal to C upon A root 21 upon 5. This is eccentricity. Lattice rectum, the length of lattice rectum is 2B square upon A, and what is that equal to? 2 times B square, 2 times 4, which is 8 upon A, which is 5. So that tells me that a lattice rectum will be 8 upon 5. Okay, this and this. Those are the 6 things that were asked in this question, and we have found all of those things one by one. That's a complete solution of this second question. The third question says that we have x square upon 16 plus y square upon 9 equals 1. Okay, and this here, since the denominator of x square is greater, so this will be a horizontal ellipse in this manner. Yes. And the most important things to identify initially would be this A, this C, B. Let's identify these values. X square by 16, y square by 9 equals 1. A square is 16, A will be equal to 4, B square is 9, which will imply that B equal to 3. C equals under root of A square minus B square, and what will that be? 16 minus 9, which is 7. So C is equal to square root of 7. Those are the few things that we have found initially. Now once we find these few things, we can write the different parts of this ellipse. The first thing that is asked is foci. Foci will be plus minus C, C comma 0 minus C comma 0. This will be plus or minus C comma 0. That's what you have, right? Next, vertices. Vertices will be A comma 0 or minus A comma 0. This is plus or minus A comma 0. That's what we have, right? Next, vertices, the length of major axis. Major axis, the length is equal to 2A, which is equal to what? 2 times A, which is 8. Minor axis, the length of minor axis is 2B, which is equal to what? 2B is 6. This is what you have, right? What else? The eccentricity. Eccentricity is C upon A, which is equal to what? C upon A, which is root 7 upon 4. What about lattice rectum? Lattice rectum is 2B square upon A. The formula has been derived, right? In the NCERT, given directly in the NCERT as well. This is 2B square, that is 9 into 2, 18 upon 4. 18 upon 4, you will cancel a factor of 2. This will become 9 upon 2. And yes, that is the answer for this question, as you can see over here. This third question for us. The fourth question says we have x square upon 25 plus y square upon 100, and we are supposed to find all of those things. The first thing that you identify is that the denominator of y square is greater. So this will be a vertical ellipse. Okay, for vertical ellipse, the next thing that will mark is this is 0 comma A, that's the vertex. 0 comma C will be the foci over here, and B comma 0 will be the end of minor axis in this manner. Another end would be minus B comma 0, focus will be 0 comma minus C and 0 comma minus A over here. But from the equation, the first things that you will observe and identify are the values of A, B and C. So A is the bigger one, and that tells me that A square is equal to 100, A will be equal to 5. B square is equal to 25, which implies B equals to 5. C is equal to under root of a square minus b square. Okay, this minus this, which is under root of 75, and this will be equal to 5 root 3. That's what we have, right? Okay, just a minute. The value of a, let's write that correctly. A is under root of 100, which is 10, not 5. This is 10, right? And a square minus b square will be 75, right? That's what you'll have. So once we identify a, b and c, now we can easily write coordinates of foci. 0 comma c, 0 comma minus c, which will be 0 comma plus or minus c. Okay, vertices. Next we need the vertices 0 comma a, 0 comma minus a, which will be 0 comma plus or minus a, which is 10. Okay, what next? Major axis. Major axis will be 2a, which is equal to 20. Minor axis will be 2b, which is equal to 10. Okay, you have identified the major axis and the minor axis? Yes. Continuing further, we need the eccentricity, which is c upon a, which will be 5 root 3 upon 10, which will become root 3 by 2. This is what you will get. Latus rectum is 2b square upon a, and that will be equal to what? So 2 times b square is 25, 2 times 25 upon 10, and yes, this is 50 upon 10, which is 5. So that is the answer for this for this question, as you can see over here. That's the complete solution and final answer. Identifying a, b and c are the key, and along with that diagram, right? Identify the diagram and the positions will tell me the coordinates very easily, right? And rest all the things become easy. Mind you, the major axis, minor axis formulae do not change, because what we have done is the coordinates change because x and y are interchanging, x and y axis are interchanging. But other than that, we have written the formula in such a manner that the lengths do not change. Length 2a, 2b. We have written a greater than b throughout. So 2a, 2b and eccentricity and lattice rectum. These are all dependent on the lengths, right? So all of these formulae remain same in horizontal and vertical ellipse. Right. So let's continue further and talk about the next one after this. In the fifth question, we have x square upon 49 plus y square upon 36. Okay. And since the denominator of x square is greater, so this will be a horizontal ellipse in this manner. And this point will be a comma 0. This point will be c comma 0. That's the focus. Similarly, you'll have minus c comma 0, minus a comma 0. This point will be end of minor axis 0 comma b. Similarly, the other end of minor axis will be 0 comma minus b. So we need a, b and c for this. X square upon 49 plus y square upon 36 is equal to 1. Identify the value of a. Since a square is 49, a will be 7. B square is 36, b will be 6. C is the value of c is equal to under root of a square minus b square, which will be a square minus b square. You can see this is 13, so c will be square root of 13. Once you identify a, b and c, now writing the coordinates of foci will be very simple. Foci is c comma 0 and minus c comma 0. This is plus minus c comma 0. Next, vertices. A comma 0 or minus a comma 0. This is plus or minus a comma 0. That's what you have. Next, we have major axis, which will be equal to 2a, and that becomes 14. Minor axis, which will be 2b, and that becomes equal to 12. Yes. Next, we have eccentricity, which is c upon a, and that tells me that eccentricity will be equal to c upon a, which is root 13 upon 7. Latus rectum, which is 2b square upon a, will be equal to 2 times b square upon a, which is 72 upon 7. And yes, all of these form part of the answer for this question, as you can see over here. That's the complete solution of this fifth question. In the sixth question, we have x square upon 100 plus y square upon 400 equals 1. So identifying the first thing, that is coefficient, denominator of y square. Denominator of y square is greater. So we'll have a vertical ellipse over here. Okay, this will be 0 comma a. This will be 0 comma c. This will be b comma 0. So vertices will be 0 comma a, 0 comma minus a. Foci will be 0 comma c, 0 comma minus c. Ends of the minor axis will be b comma 0 minus b comma 0. And this here is the center, right? Identifying the values of a, b and c are important. Let's do that. This is x square upon 100 plus y square upon 400 is equal to 1. A is the greater one, so that is square root of 400, which is 20. B is the square root of 100, which is 10. C is under root of a square minus b square, which is equal to 400 minus 100 under root of 300, which is 10 square root of 3. This is what you have, right? Yes. So on the basis of a, b and c, we can identify the coordinates of foci, vertices easily. Foci will be 0 comma a, 0 comma minus a, which will be 0 comma c, 0 comma minus c, foci, right? 0 comma c and 0 comma minus c, which will be 0 comma plus minus c, which is 10 root 3. Vertices will be 0 comma a, 0 comma minus a, 0 comma plus minus a, which is plus minus 20. That's what you have. Major axis will be 2a, which is equal to 40. Minor axis, which will be 2b, and that is equal to 20. This is what you observe, right? Few simple things. And what else? You need the eccentricity, which is c upon a, and that becomes c upon a, 10 root 3 upon 20, which is root 3 upon 2. What about lattice rectum? Lattice rectum is equal to 2b square upon a, which is 2 times b square, 100, upon a, which is 20. So you get 10. That's the length of lattice rectum. And the answer for this question is all of this, right? That's the 6th question for us over here. The 7th question says we have to solve this one and find all the conditions for this particular ellipse. If you observe, this ellipse is directly not given in the standard form. So first what we'll do is we'll convert it into standard form by dividing by this 144 so that we get a 1 on the right hand side. Yes. So this particular ellipse is equal to 36x square plus 4y square upon 144 is equal to 1. Okay. What next? This is 36 times what? This is 4 plus y square upon 36 is equal to 1. If you observe this carefully, the denominator of y square is greater. Since the denominator of y square is greater, this would be a vertical ellipse in this manner. Yes. The vertices will be 0 comma a and 0 comma minus a. The foci will be 0 comma c and 0 comma minus c. Ends of minor axis will be b comma 0 and minus b comma 0 over here. This will be the center. And the key is to identify a, b and c, the values of a, b and c for this equation. A, as you can observe, is the bigger one, right? 36, and its square root, a square is 36, a will be equal to 6. B square is equal to 4, b will be equal to 2. C can be found with the help of this, under root of a square minus b square. What is that? A square minus b square is 32, under root of 32. What is that? 16 times 2, which will become 4 root 2. That's the value of C. Okay. And now finding coordinates of foci and vertices will not be difficult. Coordinates can be found easily, right? Coordinates are dependent on the position, horizontal or vertical, right? So foci 0 comma c, 0 comma minus c will be 0 comma plus or minus c. Vertices 0 comma a, 0 comma minus a, 0 comma plus minus a. These will be the vertices, right? Foci and vertices, once you have found those things, the next thing that you need are minor axis, which is equal to 2a, and that becomes 12. The next thing is major axis, which is equal to 2b, and that becomes equal to 4. Eccentricity, which is equal to c upon a, and that becomes equal to 4 root 2 upon 6, which is 2 root 2 upon 3. Lattice rectum is equal to 2b square upon a. That's the formula for lattice rectum, right? Length of lattice rectum will be this, which is 2 times b square, which is 4, upon a, which is 6. This is 8 by 6, which is 4 by 3 actually. 2 gets cancelled, and this complete thing gives me the answer for this question, right? That's the final answer for this complete question over here. That's the 7th question for us. In the 8th question, we have 16x square plus y square equals 16. Okay, let's rearrange this in the standard form once again. What do? We divide by 16 throughout, right? Throughout. So that tells me that this will become x square plus y square upon 16 is equal to 1. This is actually x square by 1, right? So x square by 1 plus y square by 16 equals 1. And if you observe, the denominator of y square is greater, right? If the denominator of y square is greater, this will be a vertical ellipse as this. Okay, this point will be 0 comma a. This point will be 0 comma c. The other end point of the major axis will be 0 comma minus a. The other focus will be 0 comma minus c. The end point of the minor axis will be b comma 0. And similarly here you will have minus b comma 0. So the important things to find in this question, first of all, are the values of a, b and c. Let's take a look at that. X square by 1 plus y square by 16 is equal to 1. The value of a can be found with the help of this 4. Value of b will be square root of this is 1, and c will be square root of a square minus b square. What is that equal to? A square minus b square will be root 15. That's what you'll get, right? This is what we have. Once you have found a, b and c, writing the coordinates of focus and vertices will be very simple. So, foci. The coordinates will be 0 comma plus c, 0 comma minus c, which will actually be 0 comma plus or minus c, which is root 15. Vertices. For vertices, we'll have 0 comma a or 0 comma minus a, which are 0 comma plus or minus a. Next, we need the major axis and minor axis, which is 2a, and that becomes equal to 8. The minor axis is 2b, and that is equal to 2. Eccentricity, which is c by a, is equal to c by a, which is root 15 upon 4. Lattice rectum, the length of lattice rectum will be 2b square upon a, and that will be equal to 2 times b square upon a, which is this, and this is equal to 1 by 2. This is the overall answer for this question, as you can see over here. This is 8th question. The 9th question says for 4x square plus 9y square equal to 36. Okay, let's divide by 36 throughout. And this becomes x square upon 9 plus y square upon 4 is equal to 1. Okay, this is the ellipse now. And what next? Do you observe that the denominator of x square is greater? Yes. So this will be a horizontal ellipse in this way. Okay. The ends of major axis will be a comma 0 and minus a comma 0. Foci will be c comma 0 and minus c comma 0. Ends of major axis will be 0 comma b and 0 comma minus b here. Right. The important thing once again, the values of a, b and c. So for x square by 9 plus y square upon 4 equals 1, we have a equals 3, b equals 2 from here. C will be square root of a square minus b square, which is equal to 9 minus 4 under root 5. Okay. Now the foci can be found easily. C comma 0 minus c comma 0, which which will be plus or minus c, that is root 5 comma 0. The vertices, once again, a comma 0 minus a comma 0, which is plus or minus a comma 0, right? Major axis is equal to 2a, and which becomes 6. Minor axis is equal to 2b, and this is equal to 4, right? What else? Eccentricity is c by a, which is equal to c by a, root 5 by 3. Latus rectum is equal to 2b square upon a, which is equal to 2 times b square upon a, which is this. This becomes 8 by 3, and this is my answer for this question over here. This is the 9th question for us. As you can see, those are the final things that we require for this question. Let's move on to the next question. The 10th question, word exchange. In each of the following exercises 10 to 20, find the equation for the ellipse that satisfies the given conditions. Okay. For finding the equation of ellipse that satisfies this given condition, first we'll draw the approximate plot, right? We'll mark these points on the Cartesian plane and see whether, first of all, the ellipse is a standard ellipse, and which standard ellipse is this? Is it a horizontal one or is it a vertical one? We'll observe those things over here, right? So let's see. Vertices, as you can see, vertices and foci both lie on the x-axis, so this looks like this kind of a horizontal ellipse, right? Yes. And the important things that are written over here, given over here, this is c comma 0, this is a comma 0, and if you observe carefully, the equation first of all will be x square by a square plus y square upon b square equals 1. This is the equation of ellipse. Let's, on the basis of those given conditions, let's identify the value of a and b. A and b are required, right? But what is given? Foci is given, c plus minus 4 comma 0. So c will be 4 given. Foci, on the basis of this, c will be 4, and vertices is plus minus 5 comma 0. This is 5 comma 0. So a will be 5. Now these are two things which are already known. Okay, and we also know that c square is equal to a square minus b square. That tells me that b square is equal to a square minus c square, which gives me b square is equal to a square minus b square, which is 25 minus 16, that is 9. Okay, b square equals to 9, therefore equation of the ellipse will be x square by a square, which is 25, plus y square upon b square is equal to 1. It will be a horizontal ellipse, and yes, this will be the equation of that horizontal ellipse. That's the final answer for this question over here. The important thing, once again, finding the values of a and b with the help of whatever is given. C was given, so with the help of c we found values of a and b, right? That's what we have. In the 11th question, it says vertices at this point and foci at this point, right? So vertices, as you can see, vertices and foci both lie on the y-axis. So this will be a vertical ellipse in this manner, right? Equation will be x square by b square plus y square by a square is equal to 1. This is what you have. This is a vertical ellipse. This point is 0 comma c. This point is 0 comma a. Vertex 0 comma minus a. Focus, one is 0 comma c, the other is 0 comma minus c. Okay. So with the help of given data, with the help of given information, we can identify that c will be equal to 5, okay, and a will be equal to 13. Okay, the next thing that we need is b. So c square will be equal to a square minus b square. That's something that we are aware of. So b square is equal to a square minus c square. And what is that? This is 13 square, 169 minus 5 square, which is this, and this is 144. So b square is actually 144, b is 12. And what do we need? For equation we need b square, x square upon 144 plus y square upon a square, which is 169 is equal to 1, will be the required equation for this question over here. As you can see, denominator of y square is greater. So yes, this is a vertical ellipse, as you can see over here, right? That's all that you have in this question. Question number 12 says that vertices are at plus minus 6 comma 0 and foci at plus minus 4 comma 0. Now, can you identify that the vertices and foci lie on the x-axis? So this is a horizontal ellipse, right? This is a horizontal ellipse. This is vertex, which is a comma 0. This is focus, which is c comma 0. And similarly, we have minus c comma 0, minus a comma 0. This will be 0 comma b. The equation of the ellipse will be of this form: x square by a square plus y square by b square is equal to 1. The important thing once again to identify is the values of a and the value of b. Okay, so given the conditions, can you identify that vertices at plus minus 6 imply that a will be equal to 6 and foci at plus minus 4 implies that c will be equal to 4. Okay, and once we have a and c, we know that c square is equal to a square minus b square. That tells me that b square will be equal to a square minus c square. What is that? 36 minus 4 square, which is 16. That tells me that b square will be equal to 20. Okay, therefore equation of the ellipse will be x square upon a square plus y square upon b square is equal to 20. That is the required equation for this ellipse in this question. Next, 13th question says that ends of major axis are this and ends of minor axis. Okay, in this question we are given ends of major axis and ends of minor axis. If you identify major axis, the endpoints lie on the x-axis, right? So once again we have a horizontal ellipse in this manner. This will be a comma 0. This here is c comma 0 focus. This here is 0 comma b. Okay, equation of ellipse will be x square by a square plus y square by b square is equal to 1 for this horizontal ellipse. Yes, and from the given conditions we know that major axis endpoints plus minus 3 comma 0 imply that a equals 3 and b equals 2, and that is all that we need, right? Therefore equation becomes x square by a square, which is 9, plus y square upon b square, which is 4, equal to 1. That's the required equation for this question over here. That's the 13th question for us. The 14th question says that ends of major axis, okay, ends of major axis, there is a comma over there, 0 comma plus minus root 5, and ends of minor axis. Okay, once again we are given ends of major axis and minor axis, but this time the major axis endpoints lie on the y-axis, so this will be a vertical ellipse. In this manner, this will be a vertical ellipse. 0 comma a will be this, 0 comma c will be the focus, and b comma 0 will be one endpoint of the minor axis. Equation will be x square by b square plus y square upon a square is equal to 1, for which we know that ends of major axis being 0 comma plus minus root 5, 0 comma root 5 implies that a is equal to root 5. B for minor axis 0 comma plus minus 1, sorry, plus minus 1 comma 0, we have b equals plus 1. Therefore equation becomes x square upon b square, which is 1, plus y square upon a square, which is 5. This is equal to 1. That is the required equation of the ellipse and the final answer for this question, right? That's 14th for us. The 15th question says length of major axis is 26 and foci are plus minus 5 comma 0. Okay, the foci are plus minus 5 comma 0, they lie on the x-axis, right? So we have this standard ellipse. This is c comma 0, this is a comma 0, this is 0 comma b. Okay, equation will be x square upon a square plus y square upon b square is equal to 1. This is the required equation of the ellipse. Okay, for this equation we are also given that the length of major axis is 26, that is 2a is equal to 26, and foci being plus minus 5 comma 0, we have c is equal to 5. This further tells me that a is equal to 13. Okay, the two things that we need are a square and b square. We have A, we can write A square. What about B? So since C square is equal to A square minus B square, we can say that B square is equal to A square minus C square, which is 169 minus C square. C square is 25, which is equal to 144. This implies that B square is equal to 144. Therefore, required equation will be x square upon A square, which is 169 plus y square upon B square, which is 144 equals 1. This is the required equation of the ellipse in this question. Okay. In the 16th question, we are given length of minor axis as this and foci as this. Okay, so foci, if they are on the y-axis in this manner, you will have a vertical ellipse over here. Yes, this will be a vertical ellipse, and this will be 0 comma A, this will be 0 comma C, this here is B comma 0. Equation will be x square upon B square plus y square upon A square is equal to 1. If this is the equation of the ellipse, then what else? Length of minor axis is 16. Okay, this is the minor axis. The length of minor axis is 2b. So it is given that 2b is equal to 16. Foci being 0 comma plus minus 6. So 0 comma 6, 0 comma minus 6. That implies that c will be equal to 6. Here I get the value of b as 8. What else? Can I find a as well? Yes. We have a relation c square is equal to a square minus b square, and that tells me that a square will be c square plus b square. C is 6, 36 plus 8 square is 64. So the value of a square is 100. Therefore, equation of the ellipse will be x square upon b square, which is 8 square, plus y square upon a square, which is 100, equals 1. This is the required equation of this ellipse over here. Next, foci are given as plus minus 3 comma 0 and a is given to be 4. Okay, mind you, in the original, in the standard equation, a is the one of the endpoints of the major axis, right? That will decide the endpoint of the major axis. So foci being plus minus 3 comma 0, the ellipse will be a horizontal ellipse in this manner. Yes, this is a comma 0, this is c comma 0, and this here is 0 comma b. Okay, so the equation will be x square upon a square plus y square upon b square is equal to 1. This is the required equation of the ellipse, wherein from the given conditions I know that a is equal to 4, that is one thing that is sure, and foci being plus minus 3 comma 0, we have c equals 3. Using these two, I can find, along with using these two and this condition, I can find b square easily. This is a square minus c square. And what is a square? A square is equal to 16. What is c square? C square is 9. This becomes 7. Okay, so b square is 7. Okay, therefore equation of this ellipse becomes x square upon a square plus y square upon b square is equal to 1. This is the required equation for this question, right? This is 17th question for us. 18th question says b is equal to 3, c is equal to 4, and center at the origin, foci on the x-axis. That's what we are given. So in the standard equation, these are all standard terminologies. B and C are standard terminologies. Center at the origin, foci on the x-axis, right? Foci on the x-axis, center at the origin implies this is a standard horizontal ellipse, right? This is a comma 0, 0 comma b, and this here is c comma 0. Equation is x square upon a square plus y square upon b square is equal to 1. And for this standard ellipse, it is given that b equals 3, c equals 4. Okay, we are given b, but we are not given a. Can we find a? Yes, we know relation between c square, a square, and b square. Okay, so from here I know that a square is equal to b square plus c square. What is that? 9 plus 16, which is 25. Okay, that's pretty simple. Yes. So therefore equation for this particular ellipse will become x square upon a square, what is that, 25, plus y square upon b square, which is 9, is equal to 1. That's the required equation for this ellipse. That's the required ellipse here. Yes. 19 question says we have center at 0, 0. Okay. Major axis on the y-axis and passes through the points this and this. Okay. So center at 0, 0 and major axis along the y-axis implies that this will be a vertical ellipse. Yes, in this manner. This is 0, b, 0, a over here. Since this is the major axis, this will be represented by 0, a. This here is b, 0, and this here will be 0, c. Similarly, the other focus will be 0, minus c. The other end of the major axis will be 0, minus a. The other end of the minor axis will be minus b, 0. And the equation will be x square upon b square plus y square upon a square is equal to 1. This will be the required equation. Okay, we need the values of a and b, but centered 0, 0, major axis on the y-axis, we cannot find the values of a and b from here. It passes through the points this and this. Okay, for finding these two, we needed two conditions, and the two conditions are given in that manner. 3, 2 and 1, 6 are the points through which this ellipse passes. So let's apply those conditions. If the ellipse passes through 3, 2, that implies that you will have 9 upon 3 square, that is 9 upon x square, plus 9 upon b square. This is 9 upon b square, plus 4 upon a square is equal to 1. And if the ellipse passes through 1, 6, that implies that you will have 1 upon b square plus 36 upon a square is equal to 1. Okay. Let's call this equation 1 and this is equation 2. Okay, now we are supposed to solve for a square and b square with the help of these two equations. Okay, observe carefully. This can be multiplied with 9 and subtracted to eliminate b square, right? So equation 1 minus 9 times equation 2. What does that give me? 9 minus 9, b square will go. This is 4 by a square. 9 times 36. Now what is 9 times 36? This is 360 minus 36, which is equal to 324. So minus 324 upon a square is equal to 1 minus 9 times this one, which is 9. Okay, this becomes minus 320 upon a square is equal to minus 8, or a square is equal to what? 8 times 4, this is 40. A square is simply equal to 40. Please observe that calculation. It is a simple calculation, but nevertheless, a square is 40 that we obtain over here. What else? Can we find b as well? Yes. So we can use this a square in any of these equations to get b square. Or in other words, we can eliminate a square and get b square using that idea as well. Now 4 times 9 is 36. So I can multiply this equation by 9 and eliminate, subtract to eliminate a square, right? So 9 times equation 1 minus equation 2 gives me 9 times 9 is 81 minus 1, that is 80 upon b square. And this will be 9 times 4, 36 upon a square minus 36 upon a square is gone. 9 times 1 minus 1 is 8 actually, and that implies that b square will be equal to 10. Okay, so do you observe that b square will be equal to 10? Once we have a square and b square, I can easily write the equation of ellipse with this. Therefore, equation of the ellipse will be x square upon b square plus y square upon a square is equal to 1. This is the required equation of the ellipse. That is the required answer for this 19th question, as you can see over here. The 20th question says we have major axis on the x-axis and passes through the points 4, 3 and 6, 2. What about the center? Okay, the person has not mentioned the location of center. He should have mentioned that the center is at origin. Otherwise, it will not be a standard ellipse, right? Major axis on the x-axis, we can have varied ellipse in that case, right? One condition will be missing. So if you add that center is at 0, 0, if this is given, then I can write the equation, right? Major axis on the x-axis, so this will be a horizontal ellipse. This is a comma 0, this is 0 comma b, this is c comma 0. Equation will be x square upon a square plus y square upon b square is equal to 1, right? This is important, mind you. Without this, we will not be able to write this, and therefore we will not be able to solve the question, right? So here we have major axis on x-axis and passes through the points 4, 3 and 6, 2. So we need a and b, and for finding a and b we are given two conditions, right? 4, 3 lies on this implies that 16 upon a square, 9 upon b square is equal to 1. This is what we have, right? What else? 6, 2 also lies on this. Therefore, 36 upon a square plus 4 upon b square is equal to 1. Okay, this is equation number 1, this is equation number 2. And let's try to find a square and b square by eliminating, right? Observe, let's try to eliminate b square first. 9 and 4, the LCM will be 36. We'll have to multiply this by 4 and this by 9 over here, and then subtract. 36 upon b square will get cancelled, right? So let's multiply equation 1 by 4 and equation 2 by 9 and subtract them, right? Equation 1 multiplied by 4 will tell me this is 64 upon a square minus equation 2 multiplied by 9. 9 times 36 is 324 upon a square will be equal to, okay, the terms of b square, 9 times 4 36 minus 4 times 9 is 36 will get cancelled. This will become 4 minus 9. Okay, what does that give me? This is 64 minus 324, which is minus 250, right? Minus 260, sorry. Minus 260 upon a square is equal to minus 5. That tells me that a square will be equal to what? Minus 260 upon a square equal to minus 5 implies a square will be 260 upon 5, which is 52. So the value of a square has been obtained. Yes. What about b square? So for finding b square, we can use this a square in any of these equations, or we can use a similar kind of elimination as well, right? So eliminate this a square. LCM of 16 and 36. Okay, 16 and 36, the LCM will be 144. This has to be multiplied by 4, this has to be multiplied by 9. Okay, so equation 1 multiplied by 9 minus equation 2 multiplied by 4 gives me 16 times 9 is 144, 36 times 4 is 144, this will get cancelled. 1 times 9, this is 81 upon b square minus 4 times 4, 16 upon b square is equal to 9 minus 4. Okay, this is 5. And 81 minus 16 is 65. So b square will be equal to 65 upon 5, which is 13. Oh, we have found the value of b square as well. Yes. And once we have found a square and b square, therefore equation of the ellipse can be written with the help of this. Equation of the ellipse will be x square upon a square. A square is 52 plus y square upon b square, which is 13. This is equal to 1, and yes, this is the required equation of ellipse. That's the final answer for this 20th question, as you can see over here. Okay, so this is the complete solution of exercise 11.3 that we have discussed over here, and this exercise was based on standard equations of ellipse. In the next exercise, we'll be talking about standard equations of hyperbola. Till then, all the best.